Okay, so picking up right where we left off, we found our vertex using the formula x equals negative b over 2a. Once we got our answer, which was 1, we knew the x value of our vertex. We took that 1 and plugged it into the x values of the original right in there, and we ended up finding our y value. We ended up working it out to 3 plus 5, which was 8. So our y value was 8. We graphed 1, 8. We drew the axis of symmetry, which is a vertical line, the reflection line right through the vertex. We already know, because the a value is negative, that it's going to open down. So that vertex value is a max value. We just need some more points. The thing is, we don't know if it's way out here, or if it's narrow, or if it's super narrow. It all depends on your other values. Now, the point is to select values that are on the same side of the vertex, or on the same side of the vertex or axis of symmetry. So if you want to pick points on the left side, go for it. Make sure you pick both points on the left side, or you can pick both points on the right side. So which value would be easy to plug in for x? Which would be the easiest value to plug in for x right here and here? The easiest value. 0. Thank you. So we're going to plug in 0 for x. And let me ask you this. Is the x value of 0, this is negative 9 on x, this is negative 10 on x, here's 0 on x. Is that on the left side or the right side of the axis of symmetry? It's on the left side. So since I picked 0 on the left, I don't want to pick 1 or 2 or 3 because those would be on the right. Right? So let's pick another value on the left. Negative 1. Sure, why not? Negative 1. So with those 2 points, we'll have enough. Okay? As a matter of fact, with 1 point, we'll have enough. Let me show you what I'm talking about here. If I plug in 0 for x into the original, 0 squared is 0, negative 3 times 0 is 0, 6 times 0 is 0. So you really have nothing plus 5. What's your answer going to be? 5. So with that, we already have a coordinate. So check this out. Let me go to 0, 5, 0, 1, 2, 3, 4, 5. It's right here. And because of the axis of symmetry, I know that that's my reflection line. It's like a mirror. So if I'm 1 unit away from it, I could just map it over. I'm not going to do that yet, though. I want to go forth and finish up this other coordinate, negative 1. I'm going to plug in negative 1. Maybe I should show my work. Sorry, this was a picture from before. So I want to show my work on this one. I want to go the full original equation. Instead of x's, I want to put parentheses. I'm going to plug in a negative 1 into the x spots. So when I plug in negative 1, when I plug in negative 1, I'm going to end up with a negative 3 times 1, because negative 1 squared is positive 1. And then I have a plus 6, and then times negative 1, and then plus 5. So I really have a negative 3 with the minus 6 with the plus 5, which is going to be a negative 9 plus 5, which is negative 4. So when I plug in negative 1, I end up with a negative 4. So if I go to the coordinate negative 1, negative 4, I end up right here. And you could map that over. Okay, so once again, the whole purpose of drawing this axis of symmetry is to only get 2 points and then reflect them to the other side. So if this first one was 1 unit away, I'm going to map it over. There it is. If this other point was 2 units away, I'm going to map it over. And there it is. So I have my perfect, very narrow parabola with arrows on it. You got it? And that's how we graph. That's how we do. Let me move on. Let's move on to this last one right here. So let's graph this thing. What's step 1? Anybody? Step 1. Find the vertex. And the vertex is really a coordinate, an x and a y value. How do I get the x value? That's exactly right. X equals negative b over 2a. Now, what is the b value in this guy? What's the b value? 0. There is no b value. Remember, standard form is ax squared plus bx plus c. Do you have an a value? Yeah, the a value is 1 because ax squared. Is there a regular x term? No, so there is no bx term. So your b value is 0. Now if you think about this, when you say that your b value is 0, negative 0 over 2 times a, which in this case is 1, negative 0 is still 0, and 0 divided by anything is what? 0. So your x value of your vertex is 0. Now, what's your y value going to be? You take the 0, you plug it back in, you could do this in your head. What's your y value? Y equals negative 3. So your vertex is 0, negative 3. Let's go to that vertex 0, negative 3. 0, negative 1, negative 2, negative 3 is right here. Is this parabola opening up or down? Remember, if the a value is positive, it opens up. If the a value is negative, it opens down. So this a value is positive, so we know it's going to open up. Once we draw our vertex, we like to draw an axis of symmetry. Right here, it's really not that necessary. In this case, we know that the axis of symmetry is the y-axis itself. And you could draw it if you want. That'll give us a reflection. We need more coordinates. How do we find more coordinates on any function? How do we find more coordinates on any function? Make an xy table, plug in some values, pull out some answers. Right? That's an ugly x. It got uglier. Okay, so let's plug in, and remember your notes say plug in 2 values that are on the same side of the axis of symmetry. So here's your x values, right? Here's 0, here's 1, 2, 3. So if you plug in 1, you can plug in 1 and 2, or 2 and 3. I would go with close ones, right? Don't go 1 and negative 1 because you're going to be doing more work than necessary. Okay, just make sure that they're on the same side, either the left side of this thing or the right side of this thing. I want to go with the right side to stay positive, 1 and 2. So if I do plug in a 1 right in here, what's 1 squared?
1.
And what's 1 take away 3? Negative 2. All right. And let's plug in a 2 in our heads right here. 2 squared is what? What's 4 take away 3? 1. Okay. Now you can plug in as many points as you want, right? Let's do one more, just for kicks. 3. What if I plug in 3 squared? What's that? 9, and then 9 take away 3? 6. So you can get as many coordinates as you want. Now, I want to map 1, negative 2. 1 on the x, negative 2 on the y is right there. I want to map 2, 1. 1, 2, and 1 is right there. And I want to map 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. I hope I got that right. And of course, we're going to map them over. Let me zoom in to make this right. Map them over to the other side. 1 unit away, so I'm going to go 1 unit away. It'll be right there. 2 units away is right there. 3 units away is right there. And all I have to do is connect my dots, and I have my perfect parabola. So, ladies and gentlemen, if we go back to the first parent graph that we did, I don't have this on this slide anymore because I deleted it, but we did have an XY table and we had something boxed in. What was that boxed in value? It was a XY table, and then down here we had something boxed in. It was 1, 1, 2, 4, 3, 9. Yay? Now it's boxed in for a reason, because any parabola with the a value of 1 is going to have this pattern from the vertex. Let me repeat that. Any parabola with the a value of 1, or even negative 1 for that matter, okay? Any parabola with the a value of 1 is going to have the pattern 1, 1, 2, 4, 3, 9 from that vertex. Let me show you what I'm talking about, 1, 1, 2, 4, 3, 9. So from this vertex, I went out 1 and up 1. And then if I go back to the vertex and I go 2 out and 4 up, I'll get there. And if I go to the next pattern value of 3, 9, I go 1, 2, 3. If I go up 9, I'll get right there. So it's a quicker way to graph. And we're going to see that on the next example. Guys, so question number 1 on the homework here, we have a standard form quadratic trinomial. This is a parabola. Is it opening up or down? It's opening up. Okay, we also said that the a value is what in this case? 1. And whenever you have an a value of 1, you might want to jot this down in your notes. The pattern from the vertex for all parabolas with the a value of 1 or negative 1 is 1, 1, 2, 4, 3, 9. Okay? Now you don't have to memorize this, but it's a great shortcut. Anytime you have an a value of 1, your pattern from the vertex will be 1, 1, 2, 4, 3, 9. So let's keep that in the back of our heads. We'll come back to it right now once we actually find the vertex. So right now let's start number 1 by doing the first step on graphing, which is finding the vertex. And the vertex you find it by doing x equals negative b over 2 times a. So when I go negative b, that's negative 2, that's the b value right there, negative 2 over 2 times a. What's the a value? We just said it was 1, 2 times 1. So when we work this out, we end up with positive 2 over 2, which equals 1. So your vertex is a coordinate and the x value is 1. That's what we just found out. How do you find the y value? By plugging your x value back into both x spots of your original equation. So I'm going to rewrite my equation with parentheses. So there's my equation with the 1 substituted in so I could find my y value. So when I go 1 squared, I get 1. When I go negative 2 times 1, that's negative 2, and I bring down the minus 1. I have a 1 minus 2 minus 1. That's going to end up giving us a negative 2 as a final answer. Negative 2 as a final answer. So that's negative 2 for my y value. So my vertex is 1 on the x, negative 2 on the y. There's my vertex. I want to draw my axis of symmetry. By the way, on this particular homework, they're asking for several things. One thing is the vertex. We just found it. Another thing is the axis of symmetry. And if you remember from the previous side, or from the previous page, it says that your axis of symmetry is the equation x equals the x value of your vertex. So your equation is x equals 1. If you go to x is 1, you draw a vertical line through it. That's your axis of symmetry. Now we normally go and we make an xy table, right? We normally go and make an xy table and plug in values that are on the same side of the axis of symmetry to find the coordinates to graph our parabola. However, if we know this pattern right here, this beautiful pattern of 1, 1, 2, 4, 3, 9, only because it's the a value of 1, we could actually go to the vertex itself and go 1 over 1 up, and you get to, you go 1 over 1 up, and you get to that point right there. So that would be the pattern 1, 1 from the vertex. If you go back to the vertex and you go 2 over, 1, 2, 4 up, 1, 2, 3, 4, you'd be right there at the coordinate 3, 2. Now, if you went 3 over and 9 up, you're going to be off the graph. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Somewhere up here. I'll do it. I'll put it way up here somewhere. Okay? And what do we do with the axis of symmetry? We map it over. So it's mapped over to here. It's mapped over to 2 units away is right here. And this one's way mapped over out here. So we could draw our parabola going through those coordinates. We didn't even have to do much math, guys. You could stop right there, or you could extend it to those points that are off the graph. And there's also a couple other things they ask, like domain and range. Okay, remember, domain are your x values going left and right. So when you think about this parabola that continues to go up and out forever, what's your domain values going left and right forever? You would say domain is all real numbers. So you'd say the D is that symbol right there. Now the range are your y values, either going up or down. Now we just said a while ago that this has a minimum value, right? It's up here, it's going down, and all of a sudden it reaches a minimum value and it curves back up. So we should understand the range is y is what? If it has a minimum value right at this, right here, what's the minimum value there? In terms of y, the minimum value is what? Negative 2, guys. All right? So this whole parabola has to be above. So y is greater than or equal to negative 2, because it actually does touch the y value of negative 2. The vertex has a y value of negative 2. And that's your domain and range.